This video will explore Seaborn, one of the beginner-friendly Python libraries for data visualization. In just a few minutes, you'll learn how to create beautiful charts using only a few lines of code. We'll cover scatter plots, histograms, box plots, heat maps, and pair plots, all using real data. You'll also see how Seaborn works seamlessly with Pandas data frames and how easy it is to customize chart styles, colors, and themes. By the end of this tutorial, you'll understand the core plotting functions you need for exploratory data analysis, machine learning projects, and data science workflows. Let's get started with Seaborn in Python. First, let's import Seaborn and Matplotlib. Seaborn is the visualization library we'll use to create beautiful statistical charts, while Matplotlib helps display and customize those plots. The aliases SNS and PLT are standard shortcuts used in almost every Python data science project. Let's start by loading Seaborn's sample dataset called tips. This dataset contains information about restaurant bills and tips. It's great for practicing data visualization because it has both numerical and categorical data. The first column, total bill, shows the total amount of the bill in dollars. The second column, tip, records the tip given by the customer, also in dollars. The sex column tells us the gender of the person paying the bill, either male or female. The smoker column indicates whether the person is a smoker or not. The day column shows the day of the week the meal took place, such as Thursday, Friday, Saturday, or Sunday. The time column tells us whether the meal was lunch or dinner. Finally, the size column records the number of people in the party. With this dataset, we can easily create scatter plots, box plots, histograms, and other visualizations using Seaborn. Now let's create a scatter plot using Seaborn to visualize the relationship between the total bill and the tip. We will put the total bill on the x-axis and the tip on the y-axis. Each point in the scatter plot represents a single restaurant visit. The horizontal position shows the total bill, while the vertical position shows the tip amount. This allows us to see how tips generally increase as the total bill gets higher. Scatter plots are very useful for identifying trends, patterns, or outliers in your data. In this case, the plot helps us quickly understand the relationship between the size of a bill and the tip that a customer leaves. The scatter plot shows that as the total bill increases, the tip also tends to increase. This indicates a positive relationship between the total amount of a bill and the tip left by the customer. In other words, when people spend more on their meals, they usually leave higher tips. By looking at the distribution of points on the plot, we can also notice some variability. Not every large bill has a large tip, and some smaller bills still receive generous tips. This suggests that while there is a general trend, other factors may influence tipping behavior, such as the server, the customer's generosity, or the size of the group. Next, we will make our scatter plot more informative by adding categories using the hue parameter. In this example, we will color the points based on the time of the meal, showing whether it was lunch or dinner. By using hue equals time, each point on the scatter plot is now colored according to the meal time. This allows us to compare tipping behavior between lunch and dinner. Looking closely at the scatter plot, we can observe that dinner bills tend to be higher than lunch bills, which is not surprising given that dinner is often a larger meal. In both lunch and dinner categories, the tips generally increase as the total bill increases, showing a clear positive relationship between the amount spent and the tip left by the customer. Adding the hue parameter to separate lunch and dinner makes it much easier to identify subtle patterns and differences in tipping behavior. For example, we can see that even for similar bill amounts, dinner tips sometimes appear slightly higher or more clustered compared to lunch tips. This visualization also highlights overlaps and clusters that might not be obvious in a scatter plot with a single color, allowing us to better understand the distribution of tipping behavior across different meal times. By incorporating this additional categorical information, the plot becomes a richer and more informative tool for exploring the data. It enables us to make more nuanced observations about customer behavior, such as noticing that larger dinner groups may leave proportionally larger tips, or that lunch bills are more tightly clustered around lower amounts. Next, let's create a histogram to visualize the distribution of total bills in the dataset. Histograms are useful for seeing how data is spread across different ranges. We will use Seaborn's histsplit function and set the number of bins to 20. which divides the range of total bills into 20 equal intervals. Each bar in the histogram will show how many bills fall into that specific range. Looking at the histogram, we can see that most of the total bills are concentrated in the lower range, roughly between $10 and $20. This indicates that the majority of customers tend to spend modest amounts, while fewer customers have very large bills. The distribution is right skewed, meaning there are some higher bills, but they are much less frequent compared to the smaller amounts. The height of each bar in the histogram represents how many bills fall into that specific range. By examining these bars, we can quickly understand the general spending pattern of customers at the restaurant. For example, it is clear that lower to mid-range bills dominate, while extreme values are relatively rare. This visualization is helpful because it allows us to see patterns that might not be obvious just by looking at raw numbers. It also provides a foundation for further analysis, such as comparing tips given for smaller versus larger bills, or examining whether mealtime or party size affects the distribution of bills. Next, let's create a box plot to compare total bills across different days of the week. Box plots are great for showing the distribution of numerical data and highlighting important statistics like the median, quartiles, and outliers. We will use Seaborn's box split function, setting the x-axis to the day column and the y-axis to the total bill column. This will create a separate box for each day, allowing us to see how the total bills vary from Thursday through Sunday. Looking at the plot, we can see the median total bill for each day as a line inside each box. The boxes show the interquartile range, which is where the middle 50% of the data falls, while the whiskers extend to show the rest of the distribution. Outliers appear as individual points beyond the whiskers, indicating unusually high or low bills. From this box plot, we can observe which days tend to have higher bills and which days have more variability in spending. For example, weekends like Saturday and Sunday might show higher median bills and larger spreads, while weekdays might have smaller, more consistent bills. Let's create a heat map to visualize correlations between the numerical variables in the tips dataset. A heat map is a great way to see how strongly variables are related to each other. First, we calculate the correlation matrix of the dataset using the corrects method with numeric only equals true, which ensures only numeric columns like total bill, tip, and size are included. Then, we pass this correlation matrix to Seaborn's heat map function. We'll also use the map equals cool warm color map to make it easy to see positive and negative correlations. The heat map shows the values range from -1 to 1, where 1 indicates a perfect positive correlation, -1 a perfect negative correlation, and 0 no correlation. We can see, for example, that total bill and tip have a strong positive correlation, meaning that as the total bill increases, tips generally increase as well. Using a heat map makes it easy to identify relationships between variables at a glance, and the color gradient provides a clear visual cue about the strength and direction of these relationships. Next, let's explore how changing Seaborn's theme can make the histogram of total bills look different. First, we can apply the white grid theme. This theme gives the plot a clean, light background with subtle grid lines, which makes it easy to read the distribution of bills while keeping the visualization professional. After that, we can switch to the dark grid theme. This aids a darker background with the grid lines, which can make the bars of the histogram stand out more and create a bolder, high contrast look. Finally, we can use the ticks theme. This minimalist style removes most of the grid lines and only shows small ticks along the axes, giving the plot a modern, uncluttered appearance. By experimenting with these themes, we can quickly change the visual style of the histogram to match different presentation needs, making our data both clear and visually appealing while keeping the same information about how total bills are distributed. That's a wrap on our Seaborn tutorial. We learned how to import Seaborn and Matplotlib, load the tips dataset, and explore it using scatter plots, histograms, box plots, and a heat map. We also saw how to add categories with hue, and how changing themes like white grid, dark grid, and ticks can make our visualizations more appealing. With these tools, you now have the foundation to explore any dataset, uncover patterns, compare groups, and present your findings clearly. Seaborn makes it simple to turn raw data into insightful, beautiful visualizations, and you're ready to start experimenting on your own.